Okay, Lancers, here we are with 12.4, and this is going to be part one of two parts. So in this section, we're talking about angle measures and segment lengths. So what the heck does that mean? First of all, let's just do a little bit of review. Remember in the previous section, we talked about how if we have a chord, that's a wonderful circle, and it looks something like that. That was in 12.2. We talked about how that relates to the arc, right? So that is your intercepted arc. And then after that, we talked about, well, what if that we had two chords? And those two chords, we said that if this is x here, then the intercepted arc is going to be 2x degrees. And just as a quick review, let's do another circle, right? And let's talk about our central angle. And so let's just try to make that match the previous example. So if this guy was 2x, then that angle was 2x. Okie doke. So just as a reminder, right, this guy here, x, is going to be half of the intercepted arc. So the next question is well, what if that angle is not on the side or not in the middle, right? So what if we had two chords that formed an angle? Something like that, right? Then there's our angle right in there. Or what if we have a tangent of some sort and maybe another line, and that's called a secant, or it's a chord, right? So this line right here, that's a secant because it's a chord, but it goes beyond. So what happens there, right? So if we take a look, we have an angle right here and an angle out there. So that's what we're going to be talking about in this lesson. Okie doke. So let's talk about our first two theorems and see how they relate to one another. The measure of an angle, let's do this. How about we measure of an angle formed by two lines that intersect inside, right? So let's highlight that guy. Inside a circle is half the sum of the measure of the intercepted arcs. So let's just kind of highlight half the sum of the intercepted arc. So basically it's the average. So here we go. So important to note that when I zoom in here, oh, sorry about that. When I zoom in here, right, this is angle 1. It's that angle, right, which is the same thing as that one because they're vertical. So I know the formula is right here off to the left. So the measure of angle 1, right, that guy right there, is going to take the measurement of the two intercepted arcs formed by the two chords or lines. They could be either one. And then you divide by half, okay? So inside, right? We're going to add that. Now check it out. What if we have two chords, or I'm sorry, an angle formed outside, right? And these are not chords. That's not a chord. That's not a chord. That's not a chord. Those are called secants, okay? So it's a new word I'm going to talk about in a second. But, and I should also mention that this guy, not that one, I'm sorry, this guy, and that one, those are all tangents, which you do know. Okie dokie. So let's take a look here. If we take a look with the angle on the outside, right, what we're going to do is we're going to take our two intercepted arcs again, right, our two intercepted, and remember this is a tangent, so it's only 1 point, but two intercepted arcs, and we're going to subtract them, and we're going to divide by 2 again. All right, so that when it's outside, boom, 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 make sure you subtract. Now, it's important to note that x is first, right? And the reason why it's first is because this guy needs to be a positive number, right? It's going to be the bigger value. Okie dokie. So notice if we take a look at all of these x's, that x minus this y, it's going to be positive, right? That x is bigger than that y. This x is bigger than that y. All right, so let's take a look. There's a new term here. I already mentioned it a little bit, and that is a secant. And basically, that is a line that intersects a circle at 2 points. All righty, I'm highlighting that, ish. And it can be a line, right, going infinitely in both directions. It could be a ray, right? But in the end, it just has to go outside the circle, right? So a line that intersects a circle at 2 points, but one of them goes on infinitely. I suppose you can also say there's a secant segment as well, just to kind of include that. Sure, why not? But typically we don't use that. We just call that a chord. All right. Is a chord a part of a secant? Yes. Okay, so hopefully that makes sense. Sorry for the little interruption there. Moving on, we have a proof here, and as I promised, I am not going to look at proofs. So let's take a look at a few problems just to help us through here, and if we need to do more later on, just let me know. But it says, what is the value of each variable? So remember, when we say inside the circle, that is plus. We have an example out here, and that is outside the circle, and that is subtract, right? So what is the value of x? And so we're going to say the value of x is going to be equal half times the measure of one measure of arc, I should measure of one arc, plus the measure of the other arc. Okie dokie. So just simplify that, throw that into your calculator, and you have x is equal to 68, and it should be degrees. Okay, and now let's take a look at the next one. Oh, and one thing I should say too, and you'll get these in problems, and they'll sometimes say, well, what is the value of y, right? So if we just did that, then we would just make sure we say 180 minus 68 to get us that value of y, right? And so in that case, that'll just be y is equal to 112. Over at the next problem, notice again, I talked about that little mark is on the outside. And so we're going to look here and just make sure you take note. I'll change that to red. Make sure you just take note there. And the question is what is angle Z? Okay. And so let's set that up here. Now remember, this angle here, right, we're going to treat like we did over here, right? So that angle is equal to the half times the difference of the two intercepted arcs. So we are going to say 20. Again, remember half. The intercepted arcs, we're going to take the big one, 95. And, oh wow, sorry about that. And subtract by z. And so, okay, question might be, okay, well, how do we simplify from here? We can use a distributive property with this half. Another thing you can do is just simply multiply both sides by 2, right? Those halves are going to go away. And let me change that back to red. So we have 40, 95z, right? Brings, just kind of move things around to get to z. I'm going to trust that you guys know how to do that at this point. And the answer is 55 degrees. Okay. I think that should be good enough, but what the heck? Let's go with one more. Let's pick out 7. Should we pick out B? Why not, right? Pretend that this is a little quiz question here. What is y? So y is going to equal, and notice this is outside, so half times. We're going to get the difference between these two arcs. Go with the big arc. Ooh, I don't like that one. All right, and so therefore, we're going to say half times, and then 110 minus 30, and that should be 40. So hopefully that helps. There is a word problem down here also, which is essentially the same thing, but it gets a little tricky. And so I'm going to do this one with you guys. And so it basically says, I'm just going to sum up the question for you. What is this value right there? All right, what is the value of this surface of the Earth? Knowing that this is 115. And if you press pause and you try it on your own, hopefully you say, hey, wait a minute. There are no numbers on this side, right? There's no numbers over here. I don't see any numbers. There's no numbers. Well, check it out, right? if we know that this is x, right? If we assign this value of x, which we're trying to find, then that guy is going to be 360 minus x. So hopefully that makes sense to you, right? And these are both tangent lines, so we get to cut them off right there. It's a great quiz question or test question, so hopefully you guys watch this and maybe I'll include it. So let's take a look, right? So we have the point outside, so again that is subtraction. So we are going to say 17.5 equals 1/2. And what is the bigger side? This guy is the bigger side. So 360 minus x. Subtract that little side, right? Minus x, and I'll do that. So we're just going to slowly work our way to solving for x, right? So I have 17.5. I'm going to keep my half. And so what does this guy become? Well, get rid of those parentheses. That simply becomes 360 minus 2x. And just like I did in the previous problem, you have the option of distributing that 1/2. You could totally do that. So we'll just do that this time. Or you can take the option of multiplying both sides by 2. But in this case, we're going to just do this one. We're going to do it a little bit differently just to show you how it's done. Oops, sorry about that. So if we take that 1/2, distribute that into both of those. All right, let me just kind of clean this up for you. Here's what we're left with, right? 17.5 equals 180 minus x. Move the 180 over, flip the sides, do whatever you need to do just to get to x, and you will find that that is 162.5 degrees for the measure of the surface on that side. Okie doke, folks. Hope that helps for part 1, and I'll see you at part 2.